We're going to talk about the Black-Scholes formula, what it does, and how to use it. So here's the formula for the Black-Scholes without dividends. That's key distinguisher. If you have dividends, it's slightly different. So here we have the price of a call option, and remember a call is the right to buy and a future date. This is the amount that you're going to be receiving. So you're going to get stock at a certain time, and you're going to have to pay a certain price to exercise it, which is discounted. The way to think of this is think of it like a probability, and pretty much all this parameters is just calculating the probability of getting that amount of money, and think of this as getting the probability of paying that amount of money. Not entirely accurate, but it's pretty close. This accounts for the volatility, which is not actually observable. It's just kind of a made-up number that we use. You can calculate it in many ways, and that's kind of where you're trying to figure out whether the price of the stock's going to go up or down or so on. Exercise price, stock price, volatility, time, so on. So if we have our parameters here, we make up some numbers. Stock price of $50, exercise price of $51, risk-free rate of 2%, time period of 1, and volatility of 0.25. You stick that into this formula, you end up with this number, 0.125789. To calculate D2, plug that in, you get this number. How do you calculate ND1 and ND2? Well, that's the cumulative distribution function for a standard normal. Big wordy thing. Pretty much it's just calculating probability. So if we use our graphing calculator, to do it, you go to distrib, whatever that is. You're going to go for number 2. And then you need to plug in some really small number. And then your parameter here, 0.125789, end up with 0.55005. To calculate D2, it's the same thing. Negative 0.1242105, 450557, so on. Another way to do it is to use Excel. To do Excel, you just plug in 0. Your number here, normal distribution. Here, let's do another example. Equal to norm dist. That's the one you want. For your x, that's the number that you're going to be plugging in. So that's your 0.125789. Your mean is going to be 0. Your standard deviation is going to be 1, and you're saying it's true. Plug that in, you get your number here. The third way to do it that professors often ask you to do is using a standard normal chart, standard normal distribution, and all you have to do is find the number and the corresponding, find the number that you're looking for. We're looking for 0.125, 0.1, and then 25, it's about 3, so 0.125, 0.55172, 0.155172. That doesn't seem quite right, does it? 0.55. 0.5. Okay, there's just a rounding error there. All right, so this is not going to many decimal places, so this is an approximation. All right, so you can calculate that. You stick in your ND1, your ND2. You can calculate the price of a call. I guess we could do that now. See if you get the same numbers what I've got here. So our stock price is going to be $50 times 0.55005 minus your exercise price. So I got a call value of $4.97. And so pretty much all we've done here is we figured out what the Black-Scholes formula is doing, is the amount that you're getting, the amount that you're paying, and calculating the likelihood, probability, something along the lines of that, of what you're going to be paying and what you're going to be receiving. Hope that was helpful.